Hi everyone. Thank you for watching my tutorial, Intro to Digital Cartography. I'm a PhD student in geography at the University of North Carolina at Chapel Hill. I'm also a lab instructor for GIS. I got started mapping when I became a member of a critical cartography collective in the San Francisco Bay Area called the Anti-Eviction Mapping Project. Today, I hope to share some techniques I've learned to make better digital maps using QGIS and ArcGIS Online software. This tutorial is organized in 3 parts. First, I will provide a brief introduction to geographic information, which will help you understand key terms and concepts in GIS. In the second part, I will conduct an in-depth technical session using QGIS. It'll be helpful to have QGIS downloaded and opened for that portion. Lastly, I will provide you with a brief introduction to web mapping using ArcGIS Online. So what is GIS? GIS is an acronym that stands for Geographic Information Systems. GIS is a computer software that allows you to gather, organize, store, analyze, and display spatial data. In a simple sense, GIS is a mapping software. Knowing what kind of spatial data exists is helpful for finding data and navigating GIS software. There are 2 types of GIS data: raster data and vector data. Raster files are made up of gridded cells that each represent different pieces of information. Raster data can be thought of as an image data, such as an aerial photo of a landscape, a satellite image, or a scan of a physical map. We won't talk too much about rasters in this tutorial, but you should know that rasters are commonly used as base maps in cartography. There are lots of cool things that you can do with rasters, such as georeferencing a historical map or an aerial photo. The other type of data is vector data. Vector data can be points, for example, addresses or specific locations, lines, such as roads, and polygons, for example, geographic boundaries like counties, census tracts, or land parcels. In this example pictured here on the right, the wells are points, the rivers are lines, and the lake is a polygon. And all 3 are vectors. Raster data usually comes in typical image formats like JPEG, PNG, and TIFF files. Note that a TIFF file is a high-quality image format, and you may not see the full details of the image unless you view the file in a GIS or a photo editing software. TIFF files can also be a bit large. Vector data can come in a variety of file types, but 2 common ones are CSV files and shapefiles. CSV stands for comma-separated values. CSV files are usually tabular data, or what we call attribute data, in a table form. You might have a CSV file that contains names of locations, street addresses for those locations, and XY coordinates for each. You could also have a table that provides data on income by zip code. Another vector format is a shapefile, which is an important format in GIS. Shapefiles usually come as a zipped folder with multiple files that each provide specific information. It is important that you keep these files together. We will be working with these files later in the technical portion. Spatial data is organized by layers in GIS. We make maps by combining multiple layers of spatial data, and the way those layers are ordered will impact how your map will be understood. In general, points are the topmost layer in GIS. If you ordered the points below the polygons, they may not be visible. In general, remember to keep points above lines, lines above polygons, And you may even have a raster, such as an aerial image, as the bottommost layer, which is also called the base map. Now we'll talk about how you can find GIS data. Here I've assembled some sources that you can use to find and gather GIS data to get started with maps. I'm going to share my screen and show a bit about some of these. Here I'm showing you USGS Earth Explorer, which is one resource that will help you find high-resolution ortho images that you could use as a base map. I'm logged in into USGS Earth Explorer, and you can easily create a login to search for high-resolution images. So under the search criteria, I'm going to change this to address or place, and I'm going to search for Oakland, California. Here I select Oakland, California, and I'm going to search for images from January 01, 1950 to today. And this is just an arbitrary set of dates. So next, under datasets, I'm going to select, so I've moved from search criteria to datasets. I'm going to select aerial imagery, and I'll select high resolution ortho imagery. I could also select some of these other options, but I just want to see what high resolution images they have. So here are the results. Let me zoom in the map. And I can see that, so I click this little icon of an image next to this footprint, and I can see that there is a high resolution image of an area next to West Oakland. And I can look at the others. This one is covering a bit of Lake Merritt and parts of Oakland. So if I was interested in mapping some specific details here, I might download this image, which I can do here, and I could use that as a base map. So that's one option. Another option is I just Googled raster images for San Francisco because I was looking for types of historical raster images that could be used. This website from Stanford came up showing a map from 1863 that has been scanned and georeferenced. So if I zoom in here, I can see that this is the scanned map. And if I reduce the transparency, I can see that it's been georeferenced so that the points on the physical map align digitally with coordinates. And so here I could download this file as a TIFF file and I could use it in mapping in GIS. Another resource is the Library of Congress that has historical maps, but we won't be talking too much about rosters. So I'm going to show you some examples of shapefiles that you can download. So in the US, at least, most local government states have open GIS data portals. So I'm in North Carolina and I just searched North Carolina GIS data, and I can see that North Carolina has an open GIS data portal. And if I open this, I can explore all the data that they have, or I have already searched for parcels. So here I could download land parcels data for the state of North Carolina. I would probably actually want to look at a more local scale, for example, Wake County, which I know also has an open data portal. So one thing you might do is searching for the geography that you're interested in, the area that you're interested in, and seeing if there's an open GIS data portal. For example, Wake County GIS. The census The US Census also has lots of mapping files, of course, and one resource is the Tiger Line shape files, which helps you gather shapes for the US states, counties, city borders, and all kinds of administrative boundaries. And we'll use some of this later in the technical section. ArcGIS also has an open data hub with various data that you can search from all over the globe. And if you were looking to just get XY points, you could enter an address and it will give you the XY coordinates here. Okay, so one idea that you could just do is search your location and search GIS data or shape files or raster, depending on what you're interested in mapping. So now we're going to get started with the technical portion of this tutorial using QGIS. Okay, so I'm running QGIS version 3.0. Let's take a look. And notice that my computer, I'm using a Mac computer. So if you're running on Windows, it might look slightly different. So one of the things that you should know about QGIS is sort of the view settings. Here I have certain panels selected. So I have a browser view and I have layer views. And under toolbars, I also have all of the toolbars selected. We won't be using all of these, but you should know that sometimes you might encounter an issue of not knowing how to run an operation. And it might have to do with your view setting. So make sure that if you're following along with the video, that you have these panels, layers, and browser selected. So these icons here on the left are where you can import data. This icon is where you can import vector data, which we've already described as shape files or in other formats. This icon is where you can import raster data. And this icon, the little comma, is where you can import CSV files. If you were to, for example, select vector files, but you actually want to import a raster, you could just simply move to this item here. You can also drag and drop files into the layer window. So this area here is where your layers will be organized. I'm working in a blank project, so I have no data in here. But if I were to import a layer, it would show me that here. Under the browser area, if I click XY tiles, I'm going to open a base map of OpenStreetMap just so that you can see some things. These icons here allow you to zoom in or out and navigate the window. So if I wanted to see California or the San Francisco Bay Area, I would click the zoom icon and then draw onto the map, highlighting the area that I want to zoom into. If I wanted to zoom out, I could click the minimizing button. And if I wanted to see the full extent of this image, I could click this button that has sort of a magnifying glass with three arrows, and this would show me the full map extent. You should note that as I'm moving across this base map, it's showing me coordinate locations. Here I could also change the rotation, the scale, and notice that I'm using this projection. So what I did here was click this button. This is sort of the default projection, EPSG 3857. And notice that I could actually change the projection that I'm using. We won't talk too much about projections, but you should know that a projection is sort of a mathematical model of representing the Earth, which is an ellipsoid, as a flat surface. So when you represent something that is three-dimensional as two-dimensional, there are lots of issues, and you give and take in terms of shapes, distance. You compromise on a number of features. So when we get into mapping, we'll talk about using a projection that's best for the area that you're trying to represent. But for now, just notice this area is telling you what projection your project is in. So let's get started with a map. So an important detail in working with QGIS is your file organization. I've hidden all of my miscellaneous desktop files, and I've created a folder for the different maps that we'll create in this tutorial. And you might want to have some kind of similar organization where you create a folder called mapping or maps, and you might organize it by geography. If you do a lot of maps in the same area, you might want to draw from the same files, or you might create a folder for each map that you're working on. So the first map that we're going to work on is a map of San Francisco showing point data. Let me open it here. So we're going to recreate this map. So here I have, excuse me, here I have downloaded a shapefile of roads in San Francisco. And this is just a file that I found on the web because I'm not sure exactly what base map I want to use. So I will try dragging and dropping this, and notice this little dialog box pops up. So let me open that again. So as I mentioned earlier, shapefiles are usually zipped because they contain many files that usually need to be kept together. So when I drag this file, I could either drag this file and drop it into QGIS, and then I will select shapefiles, cancel, or I know that it's a vector, so I can use this icon and I will open the roads layer. And this will tell me to select the shapefile, and see the file is .shp is the file that you need to select. Okay, and then close. So you can't see the roads because this map is zoomed out showing the entire globe. So one thing that I'll do is and notice that I'm here in the layers feature, and my layers are organized such that I have OpenStreetMaps as the base map on the bottom, and above that I have the roads. If I move the roads to the bottom, definitely I can't see anything. If I move them above, I know they're here, but they're so tiny that I can't see. So I could use this zoom in icon, but a better way to do this is to right click on the layer and click zoom to layer. So this is showing me the OpenStreetMaps base map and then a vector file of all the roads in San Francisco above that. So if I want to unselect the OpenStreetMaps base map and just see the roads, I will uncheck this box. And notice I'm just seeing the roads. And if I wanted to only see the base map, I could uncheck the roads. So I'm going to unselect the base map. I was just showing you the base map to kind of get you oriented. So now I want to add a layer of points. So here I have a file of addresses as a C, and notice it's saved as a .csv file. So let me open this in Excel so you can see what the data looks like. This is a list of company names and addresses in San Francisco that I want to map. Now, I originally just had the names and the street addresses, and I manually gathered the latitude and longitude points so that I can map them as points. In QGIS, if you only had this sort of street addresses, you would not be able to map this in QGIS. I mean, you could do it with a plugin, but you really need the latitude and longitude points. So I'm showing you this CSV file because your file organization is very important. And you need to make sure you know what data you're importing into QGIS. So I'm not going to cover this in depth, but you should know that you should format your data tables appropriately so that it can be imported into QGIS without issue. So, oops. So I would not suggest dragging and dropping CSV files into QGIS. I would suggest using the delimited text, so the comma icon, and then here under file name is where you'll choose the file path to select the data companies. Click open. And notice these are field and options that we won't cover too much, but notice that this button is checked saying that the first row has the names, header names, and that first row does not contain data, only field names. Now here I know that this CSV file has geometry because it has the X and the Y coordinates. So when I import this data, it should be able to map these point locations. So I choose the X field, which is longitude. Be sure to know that X is longitude and Y is latitude. And notice that this is using the projection that these points are using is WGS 84. We won't talk too much about this, but this you should know that these points are being uploaded using a certain projection, and that projection may not be the same as your project projection. Okay, so now I have the points on the map. And here, remember what I said about layer ordering. So we have the base map, which is open street maps on the bottom. We have the roads, the lines above the base map, and then we have the points above. And you can tell it's sort of hard to see, and it's not clear that I need both of these layers. So I'm going to just remove the open street map layer by unchecking it. So one of the things that I'm noticing is that San Francisco may not be in the best projection. So I could change, so sometimes if I were to change this to, let's see, the World Mercator, and I'm just showing you that different projections will change the shape of the area that you're working for. So there's a lot of detail into this that we won't go into, but just know that what I've done here is searched San Francisco, and what comes up are good options for representing San Francisco that I'm going to use. And so this gives me a better shape of San Francisco. And I'm going to move this to the side. So one of the things that I could do is change the color of these roads, the color of the dots. What I actually know is that this is showing what looks like about 10 dots, but some of these dots are actually multiple companies that share the same address. So there's a tool in QGIS that I could use that would show sort of clusters of points that share the same location. So if I want to change the roads, let's do that again. I'm going to double click on the roads layer, and I'm in the symbology tab. So notice that you can navigate between these windows. So I'm under symbology. So notice This is showing me that the roads are using a simple brown line and the outline and the fill of the line are both brown. I'm going to change the roads to one of these sort of pre-prepared symbologies and just use gray lines. And I don't want the lines to be too heavy, so I'm going to reduce the width. But know that I could change the color of the lines manually here, and I could change the color of the outline. So here's the stroke line. I can make them dashed, all kinds of things, but you should play around with this when you get a chance. But for now, I'm just going to change the lines from brown to gray. Click OK. So these lines are a bit too thick. So I'm going to go back to this and I'm going to change the width to, and that's too thin. So, okay, that looks better. So now this is essentially the map that we wanted to replicate. But what I wanted to show you is about the cluster of points. So under symbology, notice we're showing a single symbol for each XY location, but we have a few points that have the same location. So what you could do here is use the point cluster feature. And notice this tells you that here there are actually, let me zoom in here, 46 points at this location. But for now, I'm just going to go back to single symbol and zoom to the rows layer. And essentially, we have replicated that map, the first map. And so if you want, so now this is, I'm working in QGIS project file. I want to actually export this into some kind of digital format that I could use in a report or on the web. So what I do is go to project and create a new print layout. I'm going to give it a title. Okay. And this opens sort of the layout where you'll do the finishing on your map, kind of adding the map, titles, any legends that you want to create. But we'll get into that a little bit later. I just want to show you that I click this icon, which will let me add the map to the print layout. And here's my map. Here's my map, and I might want to change the scale if I want to zoom into the map more. I would sort of reduce the scale, and I could add a title here, add text, something like San Francisco companies. And I'm not going to go too much into detail into the print layout, but know that you can change the fonts here, font sizes, font color, and all sorts of things. But if I just wanted to export this image of the map, I can export it as a PNG file. This little icon here lets me export it as a PNG file. This icon lets me export it as an SVG file, and this icon lets me export it as a PDF. So let's see, export it as a PNG. Map one example, and notice the same thing as a PNG. This dialog box pops up, and I just click save, and here's my map. Okay. Okay, so to summarize, we just learned how to import vector files, how to navigate QGIS, how to import a CSV file that has geometry, so points, and we were working with the print layout. We'll work more a little bit on styles once we get into the next map example, but I wanted to show you that I did not save this project file. So if I know that I'm working on a map that I'm going to come back to, I would encourage you to save the project, and you can go click on project, click save as, and I'm working sort of in this folder called SF points. I'm going to call this SF points example, and this will save this as a QGIS project file. So one thing to know about project files is you can't, if I were to remove any of these layers that I used in the project, so let me rewind. The project file is not storing all of these layers. These layers are stored wherever you save them on your computer. The project file is referencing those locations. So if I were to remove this roads layer or this companies layer, then my project file would no longer work. It would break sort of the organization. So just know if you're saving your project files, you should save that within the folder where you're saving the project data. And if you remove any of those, you try to reopen the project, that might be the reason it's not working. So I'm going to start a new project to work on the second map example. And what I do is I go to this icon here, which will create a new project. Okay. So for the second example, we'll get started making a Choropleth map. For this next map, Choropleth map, we're going to be working with data from a data source that I found on the web related to sort of issues of environmental equity in California and environmental health. So this data set is sort of a pre-prepared spatial data set that you could easily work with to create a customized map image. So what I've done is I've downloaded the shapefile. So Cal Enviro Screen 3.0 results shapefile, and I'm going to use that shapefile to create this next Choropleth map. Excuse me. Okay. Okay, so just to show you the example, so we're going to be recreating this map that I prepared for the tutorial as an example. Now, as I said, I downloaded the Cal Enviro Screen 3 data, and it downloaded as a zip file. This is an example of the folder unzipped. It contains all of these files, and notice that this is the shapefile. If you're working on a map on a Mac, if you simply double click the zip file, it'll unzip the folders. So I don't need two of these, but just to show you. If you're working on Windows, you might have to download some sort of unzip software in order to open the folder contents. But what I wanted to show you is the spreadsheet that the data has to sort of understand what we're going to be mapping. So the Cal Enviro screen has created sort of a composite indicator about pollution burden, and that is the CES score and the CES percentile. And it's comprised of all these other measures or attributes. So I could map using any of these other indicators. So I just wanted to show you that. But I'm going to use sort of their composite indicator that represents pollution burden across the state. Okay, so let's try dragging and dropping this zipped folder into QGIS. And QGIS doesn't like that for some reason. So what I did was double click the folder and I unzipped it. So I'm going to try instead using this import vector button. Go to map examples, example 2, and I'm going to go to my folder. And I know that this is the shapefile of the California Enviro screen results. And I'm going to click open the shapefile. So the file that's .shp. Open, click add, click OK. And here is the map. So notice again that this projection is now using EPSG 3310. And that looks like it's a good projection for California. So I won't do anything with that for now. California looks good to me. So what we want to do is this is showing sort of pollution burden by census tract. But you're not seeing that because the data is showing as a single symbol for each of the census tracts. So I want to change the symbology so that I can show the pollution burden by census tract. So I'm going to double click on the CES layer. So I'll show that again. I'll double click this layer. It opens and I'm on symbology. So notice that this is showing a single symbol for the geographic area, but I actually want to change this to graduated symbol. Now, if I had some sort of data that was qualitative, sort of like high, medium, low pollution burden, then I might use categorize, but this is using continuous data, so I'm going to use graduated. Okay, so I selected, so I went from single symbol to, and notice that QGIS is sort of default coloring these symbols, but we're going to change that. So I change this to graduated. And now I want to select the attribute, sort of the variable that I want to show on the map. And that is the CI score in percentiles. So I could choose any of these other indicators, but I'm choosing to use their composite score, and I want to use it in the percentage format. So now I'm showing, I've selected CI score P, and I'm not going to worry about the changing the color, but you should know that I can configure the symbol here. But so this is, what I'm now showing you is how to sort of classify the data. And so let's just click classify. So what this is telling you is that QGIS has organized sort of the data into 5 classes or 5 ranges of values. And you can see that in the legend. You could look at the histogram if that's helpful for you. But what I know is I want to create a map that has sort of 10 classes, one for each sort of 10 percent point range. And so I need 10 classes in order to do that. But there are some principles about classes that I won't get into here, but you should think about how you're classifying your data. But I know that since this data is sort of organized around percentage points, I'm going to just use sort of a 10 class system. Okay, so notice that these values are not going from 0 to 10. And that's because QGIS is now classifying the data according to equal count. So you should know that if I choose these different options, that will impact the data. So I could use equal interval, logarithmic scale, natural breaks, so how the data naturally breaks, and each of these will change what your map looks like. So it's important to think about the best classification for your data. And that's something you'll have to think through. But I've just decided that I want to use sort of a very clean 0 to 10, 90 to 10 classification scheme. And I don't want to use this color red. Let's say I want to use blue. And so this will show me that areas with the highest percentage of pollution burden, the highest percentage score, will be in darker blue. So let's click apply and voila. So maybe I don't think that blue is a good color for this classification. So I'm going to change, note that you can change the color ramp. So I could use reds, I could use spectral, which is what this is showing. But notice that now the areas with the lowest pollution burden will be in red, and that's sort of not intuitive. So I want to invert this color ramp so that the areas with the highest pollution burden will be in red. So click apply, click OK, and that looks pretty good. One of the things that I wanted to show you is, so you're given a few options for color schemes, but you can manually change these colors and apply sort of color principles and color theory to your map and think about what is the best color scheme for representing your data. So that's something that's a good tip for cartographers that we won't go in too much today. But know that there are websites like Color Brewer, and there are also Adobe Color that can help you with getting good color schemes to best represent your data. But for now, this looks like pretty good. Okay, so if I wanted to zoom in to an area, I could zoom in to San Francisco, and I can zoom back out, zoom to layer, or I can click this button to move out. So I think that looks pretty good. If I wanted to change sort of the outline around the census tracts, I could do that by changing symbol. So now I'm under symbology and configure symbol. I could adjust the stroke width here. I can make the fills, the strokes transparent. I can make them gray. I can do all sorts of things, but for now I'm just going to leave it as it is. But I do think that the black is a bit too thick. Okay, so voila. Okay, so now we're going to open a new print layout because I'm ready to export this map. And I'm going to click Add Map to Layout. And notice I'm actually going to zoom in to this map. And so one of the things you could also do is click this button here, which will actually move the map around within this drawn canvas. So, and you can click out of that. So if you wanted to reposition the map, you could do that using that feature. And I want to zoom in on this a bit more. And that's good enough. Okay, so I want to add a title, and I'll do that by adding text. So this gives me a text box. And if I click on it, then I notice that I'm in the item properties, and I could choose California. And I can increase the size of the font here. So under, I'm on the text box here, and I'm under item properties, and I'm going to change the font to Avenir, and I'm going to increase the font size. I'm also going to justify it. And I forgot to add the year. Okay, so now I have a map title that I could then move around or resize. And so now I want to add legend. And so what I did is collect this little icon that adds, it'll automatically create a legend from your map data. I click the icon and I draw a box and see that I have the categories here. So now if I click the legend icon, I want to rename this title, or actually even remove it. What I do is I click the legend and I go to item properties, and I'm going to click uncheck this box, auto update. And I just expanded this file. And this is sort of showing me just the generic file name from the data that I downloaded. So I don't want to, I could edit that by double clicking it, and I could edit the text. But I'm actually going to just hide that. And I'm going to change the text for each of the items by double clicking each, and then I'll add %. Okay. And okay. So I might want to actually change this text and justify it to the right. Just so that it aligns a little better. And yeah, so you should know that you can work on the print layout. I won't cover this in too much detail, but just know that you can arrange sort of how your map looks for the final print version. And I can add a text for the data source. And I could change this here, source. And that's not the full source, but just know that you could change that here, and you can change the font size and style here. Okay, so let's move on to the next example. Okay, so for this third and final map, I'm going to teach you how to perform a data join and how to clip a map to a specific area using a polygon. And that sounds a little bit vague now, but we'll go through the steps. And knowing how to join tabular data, sort of attribute data, to a spatial file is an important step that'll really help you expand your capabilities in mapping and expand the types of maps that you can make. And so it's really easy to do in GIS, so I hope to walk you through that today. Okay, so for this third map, we're going to be using a data file from the National Vital Statistics System called the U.S. Small Area Life Expectancy Estimates Project. And this data set sort of estimates life expectancy at birth for all of the census tracts for the U.S. So we're going to be working with California again, and I've downloaded this data set for California that we'll be working with today. So let's open up that file. So this is a CSV file that has no geometry. And that's an important thing to understand, is that this spreadsheet, sort of this table, is showing you census tracts, the state, some kind of county code, I think. I'm not sure what this variable is. Some other classification related to the tract. And this is actually the estimate of life expectancy at birth. This is the standard error and some other feature. So you cannot, you might think that you can import this CSV file into QGIS and it'll just know that these tract IDs sort of have some sort of shape and coordinates, but that is not the case. So let me show you what happens when I import this CSV file. So I'll click this and notice I have separate files for each of the three math examples, and I'm going to open this California life expectancy file. And notice I'm selecting no geometry because this table has no point or well-known, well, actually, yeah. Anyway, so we're going to import this CSV file as no geometry. So notice the file doesn't show you anything because there's no sort of coordinates for it. But you can view what the data in the table contains. So let's select this icon at the top, sort of an icon that looks like a little form or a little table. You click that, and down here it's showing me sort of exactly what was contained in that CSV file. So this attribute table is showing me life expectancy per census tract. What I need is a shape file of the census tract so that I can bind these attributes to a file that has geometry. So I need sort of the census boundaries to combine with this attribute table. And so I'm going to get those boundaries from excuse me. I'm going to get those files from this resource that I mentioned, the US Census Tigerline shapefile database. So I selected the year 2018, and I'm going to search for all of the census, a file that gives me shapes for all of the census tracts in California. So I click this web interface, and I'm going to select the year 2018. And just note that depending on the year impacts what files you'll be able to download. For example, if I select 2019, I might not be able to get counties or census tract. It just depends on how often they update these. But I know that in 2018, and your best bet is to use, 2010, 2000. You know that sort of those boundaries have not been redrawn. But I know that there's a file for 2018 that I'm going to use. So I selected the year 2018 and I selected census tracts and I hit submit. And I'm going to select the state, California. And I would click download. I'll just do that. And notice showing me in my downloads here. This is the second time downloading it. But this is sort of a zip file of a shape file with all of the census tracts in California as a vector file. Okay, so I want to bring in that vector. So I clicked the icon with the lines and vertices, and I am going to navigate to the data source here. Now I downloaded that to my downloads, but you should know that I have this file saved in my folder for this map example. So just know that I'm not navigating to the downloads because I already have it saved here. So here is the file for the census tracts in California. I'm going to click open, click add, and then I have to select the shape file, click OK, OK, then close. So I'm going to close this attribute table, and I'm going to zoom to this layer, and notice California looks a little bit different. So I might change that projection later. But okay, so for now, we have all the tracks. So let's open the attribute table for the shapefile. Okay, so notice that this has all of the data for the shapes, but we want to sort of join the data about the census tracts, the life expectancy, with this shapefile, this file that has geometry. Okay, so what I'm looking for is a field that I will use to match between the two files. So let's see. Let me go back to move this up. So I'm opening the attribute table on the CSV file. And I know that there's this field called tract ID, state ID. So I know that I want to join at the tract ID. So I need to figure out what field in the census tract shape files that I would match that has the same exact information as this life expectancy table. So I know that this is probably, this tract ID is what I'm looking for in the CSV file, but I need to find what field that would be in the shape file. So let's go to the shape file. And just looking at this, you know, I could tell that this tract CE would not match. And I know that this GeoID seems to look very similar to the tract ID in the CSV file. Now, you have to be careful because even if one number or mistypo will not allow this process to work, but since I know that these are sort of clean and verified databases, we're okay. But that's something you should think about if you're creating your own CSV table, is that you have to make sure that this field matches with the field in the attribute table. Okay. So now we're going to perform the join. So what I do is I go to the properties on the shapefile. I'm going to right click and click properties, or I could also just double click this and that'll also open properties. And I'm going to navigate to the joins tab. So notice I was on symbology, and I'm going to joins. So I click this little plus sign here, and notice that it's saying join layer. So I'm going to join this attribute table for California life expectancy to the shapefile. So what join field I'm going to use? I'm going to use the tract ID from the life expectancy table, and I'm going to join that with the GeoID that we've already confirmed by looking at both tables. Okay, so if something is off here, then this will not work. So it's very important to be very familiar with your data and know why you're choosing these two as the join fields. Okay, so one thing that I can check, so if I did something wrong, I could also remove this join here, but I think that worked. So I could look at the attributes and now see that the attributes for the shapefile have these attributes from the California life expectancy. So this is telling me that this probably worked. Another way that I can check is I go to symbology and I'm going to select graduated, and I should be able to select life expectancy at birth. And here I'm seeing that I can select that here. Okay, so let's see what happens. Classify the data, and that looks like it worked. So let's just, this is sort of the default classification, which will apply. And now I can tell that the shape files now have attached to them the data from the life expectancy attribute table. Okay, so I want to work on the symbology. So this is using a red color ramp, but in my example, I'm using a blue. And so I think the 5 categories is fine, but I want to change this to blues. But again, know that you can change this color ramp. You can use sort of color theory to figure out the best color scheme that works for the data you're trying to represent. And you can use those resources, Color Brewer, and it'll help you classify the data. So I don't want equal counts. I want to do natural breaks. And I might want to change the outline, but for now I just want to see what this data looks like. Click apply, and that's okay. So now we're showing life expectancy at birth for census tracts for all of California. But what I want to show is actually the San Francisco Bay Area, which is this region here. And I mentioned earlier that this projection looks a little strange to me. So I'm going to change the projection. I'm going to search California. And notice I have some options here that I've already used, but I'm going to use this projection. And this is something you don't have to worry too much about, but just know that you can change the projection to better illustrate the area, better represent the area you're working on. Okay, so I could zoom into this area, which is the Bay Area, but that won't help me if I want to sort of exclude all these other census tracts and areas. So I have a file for the Bay Area, an outline of the Bay Area that I just got from some San Francisco OpenGIS website or Berkeley or some source that I just Googled Bay Area outline shapefile, and I got this file. So I'm going to try dragging and dropping and see my layer organization. I have sort of the outline above the census tract, so it's blocking the data that I want to see. So I could click the symbology and I could change the transparency to something like this, and I could make this an outline. And now this is sort of highlighting the San Francisco Bay Area region. But if I wanted to print this map, you know, that stylistically, it would not look good with this sort of odd shape above. Really what I just want to show is this area. I want to isolate this area in the map. And one of the things that you could do is you could perform this process called a clip, which will clip the map to just the area within a certain polygon. So know that this Bay Area outline is a polygon. It's a shape of the Bay Area region. And I want to clip this entire map of California life expectancy to just the Bay Area region. So the way I do that is I click on this button called Vector, and I click Geoprocessing Tools, and I click Clip. And notice that this dialog box, I open my input layer is the layer, the census tract layer that now also has the life expectancy data. And the overlay layer is the polygon that you want to clip this data to. So I select the input layer is my census tracts that has the join with the life expectancy. My overlay layer is the Bay Area, the polygon of the Bay Area region. And now you could just run this and it'll create a temporary file, but I actually will save this and I'm going to call it Bay Area Life Expectancy. And I think I already have a version of this saved, so I will just pin number two, but this is going to save a shapefile of just the Bay Area region that also brings in sort of the life expectancy data that we've already joined. So it's just going to clip the map. It's going to give me a shapefile of just the Bay Area with the life expectancy data in it. So I click save and I click run. This is how I gave this a file path. I clicked here, save the file. I have already named it, so I'm just showing you. And I click run. Okay, click close. So notice that I can uncheck this census tract layer. I can uncheck the outline, and now I just have the Bay Area region. Now you can't see the life expectancy data now, but the way you do that is you go back into symbology and I click graduated. And there's a way that you could sort of save this style, but we won't get into that today. But I know that I had a blue color ramp, I had 5 categories, and I was using natural breaks. But I actually want pretty breaks, I think. Natural breaks. Yeah, okay. So classify, apply, and click OK. And so now I have just an area of the Bay Area with the life expectancy data in it. Now, one thing you should know is let's look at this outline. These areas in white were areas that there must have been no data on life expectancy from the small area life expectancy file. So if I were to just present this, these are not sort of like lakes or, I could tell that some of these areas are just areas that have no data. So that's something that we won't work on, but it's just something to remind you that if I add this outline, I could kind of see that these are areas that have no data. And it might be because they're, some of them are forests, but some of them just simply could not calculate the small area life expectancy. I could also rotate this map, but leave it at that. Okay, so you already know how to work in the print layout and you already know how to create a title and legend, so I won't go through that with you, but just know, hopefully now you can join data and clip to a certain area. So now that we've learned a bit in QGIS, we can get started with making web maps with ArcGIS Online. So ArcGIS Online is a web-based mapping software, and it can be free. You can create a free public account, but since most of you are university faculty, professors, and students, you can use ArcGIS Online using your institutional account. So let's see that. So I clicked ArcGIS Online sign in, and notice that I'm going to select this option called Your ArcGIS Organization's URL. So I'm at UNC, so I'm going to search UNC or type in UNC. And this will take me to my university's single sign-on page. So I signed in, entering my login credentials for my university, and now I am signed in to ArcGIS Online. Okay, so now we're looking at the Home tab. And so you should notice here is, these are important for navigating ArcGIS Online. This is a gallery which will show you different data products, maps people have created, give you ideas for the types of maps that you could create. So it's worth a while spending some time getting to know sort of the things that you can do and the data that's openly available in ArcGIS Online. This map tab will take you into the map viewer that we will be working on a little bit later to recreate one of those maps that we did in QGIS here. But for now, I'm just showing you that this is the map viewer. And if you click this button here, search for layers, this is showing me my content. I don't have anything stored in my ArcGIS Online, so that's why it's empty. But I could search all of ArcGIS Online, or I could search Living Atlas. And this is populated with, I don't know, thousands of data sources that you could use to construct your map. One thing to note is that some of these files are made by verified users. So here I can see that this was made by Esri, a very cool sort of dark schemed terrain layer that I could use as a base map. And some of these products made by Esri are restricted for people with certain kinds of subscriptions, but just know that you should be mindful of who is creating sort of the data that you're shared. Is it verified? You know, so you can use any of this. So for example, if I wanted to search environment California, you know, some maps, these are made by the California Department of Conservation. They're verified, so I could use these. But some of these are made by individual users, which they might be fine, but just note that if you're using data prepared by someone else, you should consider that. Okay, so we're gonna go back to, so I've clicked this little home icon. I wanna get out of the map viewer and I wanna go to my home tab. And I wanna go to content. So content is where you're sort of will organize and save all of the files for the maps that you create. I've created a folder for this workshop tutorial, and I don't have any content in there now, but I could add by choosing a file from my computer, or I could add from a URL. For example, if I wanted to grab one of the URLs for small area life expectancy, well, not that file, but the column Enviro screen, I could do that. But I already have it downloaded, so I'm just going to add it from my computer. Let's see, choose desktop, map examples, Enviro screen. So I'm going to bring in this zip file of the shape files. And I believe in ArcGIS Online, you need to have this zipped file. I couldn't bring in this folder, I think. So let me choose open. And it already recognizes that it's a shape file, and I could give it a new title, Enviro screen. And I think there's some limits to the numbers of characters that you could have here. You have to give it a tag. I'm going to say, oh, this will help find this data set. Okay, so add item, excuse me. And this is still loading. Okay. Okay, so here I could add a brief description of this data set. I could change a few things. I could create apps from this, but what I want to do is I want to work to style this map. So I'm going to open this in the map viewer. Okay, so now we're back to the map viewer and it should auto load this file. And it's loading. Okay. So notice I'm under the details tab, and this is where I could add, if I had other layers in my account, I could add them here. And here, notice that I can change the base map. So I'm going to change this to a dark color scheme. I could use light gray, or if I wanted some kind of landscape or place names, I could use a different base map. But for now, I'm just going to use this dark, dark gray canvas. Okay, so I want to see my content to change the symbology. So under, let's see, details, not under content, then I click, this is my layer, my shapefile file layer with the California pollution burden data. So if I click this icons, I can change the style. If I click here, I can see the attribute table. I could see the legend, but the legend, notice I'm just showing, this is not, the symbology is not categorized. It's just showing a single symbol for each of the census tracts. So I want to change the symbology. Okay, so I have to select the variable or the attribute that I want to show, and I want to use the CIP score, the percentile. So I chose that variable. And I'm assuming you remember this from the previous example, but this is sort of the composite indicator for pollution burden. And I'm not sure why this is very slow right now, but this, of course, is not intelligible, sort of representing the data in dots. So I want to choose counts and amounts, but I want to further customize this. So I click options. And this is where in QGIS you can sort of classify and change the symbology of the data. Under symbols, I could change the color. This is showing me sort of how the data is now being classified or categorized. And I'm gonna, you could hide it in the legend if you want it, but I wanna classify the data using the similar scheme that we use in QGIS. So I wanna use manual breaks. Notice the terminology is different. I want 10 classes, and it's already showing, it's already rounded, but I could round by 10 if, for example, my data looked different. Okay, so round by 10, and I can choose to draw features that have no data or out of this range. So I'm gonna click, okay, well, let's look at the outlines. So I want to give an outline to the different census tracts. And I'm gonna choose black. Maybe black doesn't make sense. I'll choose gray. Okay, that didn't seem to do much, but what we had in the other example is a spectral color scheme, and this is just showing you in blue. So I can look for that kind of, this looks somewhat similar, but know that you could use sites like the Color Brewer to customize the colors that you use. So I'm going to select this last option just because it looks a bit similar. And I click OK. But notice here that the areas with the highest burden are showing in green, which is not totally intuitive. So I want to invert this so that the red are for the areas with the highest pollution burden. And I can click this to invert the color ramp, click OK, and now I have a map. So I'm going to click OK, click done. And so one of the things to think about is when you're creating a web map, it sort of lets you interact with the different details as you scroll through the map. What I would probably do is I would clean this data set and remove some of these fields if I wanted to be very specific about what, because maybe my audience doesn't need to see the tract ID and all of these details. So I might sort of remove some of the columns that I don't want to view before I bring in that data. But assuming one other thing is you can look at the legend. It sort of pre-populates the legend based on the symbology. And what you can do is you should save this map. So I'm going to save as Cal. Giving it a title, and you always need to tag this so that it can be found. California. And I could add a description, and I'm saving it in sort of this folder. Click Save Map. And if I wanted to share this map, one thing is if I click Print, know that this is going to open up sort of an HTML that you could save as a PDF, but it's not a high resolution or high quality image, which is why I think working in QGIS gives you much more capability in producing a high resolution image, whereas ArcGIS Online is mostly for making web maps. There is a beta version of ArcGIS Online where you can save a high resolution image of your map that I haven't used, but you're welcome to look at that. But I think using QGIS and working with a software like Illustrator is much better for doing sort of finishing touches on a digital sort of map image. Okay, so assuming you wanted to embed this map into a website or just show your map, you can click the share button and know that you had to have saved your map in order to share it. And so if I want to click share with everyone, click OK. And this is saying that my data file, the Enviro screen data, was not set to public. So it's updating the sharing on the file so that it can share the map. And I can use this link to share my map on the web, Facebook, Twitter, or I can get this embed code, and that gives you some additional options. Yeah, so I could, let's grab this link and take a look at it as a HTML page, or sorry, an ArcGIS map page. And this is what users will see if you just send the link to the map. Another option is you can share by creating a web app. And this is where you could do things like create a story map. You can do all kinds of things to best integrate maybe this map with other details of the story you're trying to tell. So it's worth looking around in ArcGIS Online. There's a lot of project examples that you can use, but I won't go into that today. I just wanted to let you know that working with QGIS and ArcGIS Online can give you a lot of flexibility and allow you to better customize maps. Okay. So thank you for attending my tutorial.